Okay, everyone. Hopefully you're getting used to doing the opposite complementary and supplementary angle solutions. Today we're going to look at angles in a triangle, and hopefully you'll be able to apply what you already are working on with that, because we're going to start synthesizing these into complex diagrams, so it gets a little bit dicey, so got to pay attention. Okay, so just a quick review. So far you know opposite angles are equal. Okay, so we say angles equal, and we know that the proof is op. The other thing, and it looks like this, I always try to put a little symbol in there, like that, right? And again, kind of looks like two little fish kissing each other, or it looks like a little X, right? The other one that we looked at was complementary angles. And those you find when you see the right angle box, and you might, whoa, hang on, let's get rid of that, that was a bad line. You may find that you've got an angle in here that you have, and you've got to solve the other angle in there. So those angles equal 90 degrees, and comp is your proof. The last one is the supplementary angles, and your diagram could look like that, and we've got one angle sitting here, we've got another angle sitting there, and we know that those angles combined, and there could be more than, I could put another one in there, so it doesn't have to be two angles. Same with complementary, but that's the information that you're going to be using, and those angles equal 180 degrees, and it's sup. So far you know 3 proofs, and I think you're about to know 1, 2, 3 more. So by the end of this lesson, you're going to have 6. Okay, so at this point, I think you already know that when you add up the angle measures in a triangle, you get a total of 180 degrees. So what we can say is the sum of the angles in a triangle equal 180 degrees. So notice that you had supplementary angles were 180, and now you have sum of angles in a triangle are 180. So you're going to have 2 180 relationships so far to keep track of. And the proof is SAT. And the reason why it's SAT is that we're dealing with sum of angles in a triangle, okay? So that's where the SAT comes from. So when we look at this first diagram, I know that that equals 45, that equals 98. This is a scalene triangle, because scalene triangles have no sides that are equal and no angles that are equal. So I know that based on sum of angles in a triangle, if I add these 2 angles together, so this one and this one, and I subtract that result from 180, I'm going to be able to solve for x. Okay, so this one uses the sum of angles in the triangle theorem. Okay, I'm going to get more into examples, but I'm showing you the 3 different proofs ahead of time. This next triangle is called an isosceles triangle, and I know it's isosceles because I have two equal sides, and it doesn't matter how this triangle is organized or oriented. I could have a triangle that goes that way, right? So what you want to look at is these two angles that are equal. Those line segments that they're attached to, they join at a point, okay? And this point you don't want to factor in. What you want to do is you want to look at the other two angles in that triangle, and those angles are congruent, and that's what those symbols mean. If I have little hatch marks on any polygon, if those hatch marks look the same, that tells you that in the case of side lengths, these hatch marks here, this triangle's becoming a mess, but these hatch marks here tell you that those two side lengths are equal. And then those angles, I could have a triangle that has two like that, just with a single scoop, and that should tell you, even though my diagram is horrible, I'm telling you that those two angles are the same. If I decide that this side length and that side length are the same, which they would be based on the isosceles theorem, then those two hatch marks correspond. Okay, you've seen this before with rectangles, where if I say that that side is equal to that side, I can't just put that one like that, because that side this side does not have the same side length as the other two that I just marked off. So now I have to come in and put two little hatch marks to basically tell the reader, quote unquote, that those two things are different. So I'm going to erase all this stuff so that we have some room for the other things that I'm writing. Okay, so where you want to come in with is, you know that the isosceles, so the little ticks that tell you that the line is or that the triangle's isosceles, the two lines that they are on, like those two congruent lines, they meet at a point that is going to have a specific angle, but the other two angles are congruent. So I don't want to tell you that they're underneath those hatch marks, because this triangle that I just showed you, they're not really underneath. So I'm going to use what I just said and say, okay, well, this hatch mark and that hatch mark tells me those two lines are congruent. Those two lines meet at an angle point, which means that this one and this one are the ones that are congruent. Those two angles are congruent. Okay. The proof for figuring out isosceles triangle angles, this is like my favorite one, is isos. Okay, ISOS. So you notice that you're basically using the beginning parts of each of these proofs. And then when we come to the bottom here, notice how we've got all these hatch marks. So these are all the same. So we could have gotten away with marking it off with single hatch marks, right? No, that's horrible. And then your angles all work out to be 60, and you should know that that's because 180 equally distributed amongst three angles is 60 degrees. Okay, and you see that because these angles are measured, or sorry, they're marked. So let's come in and do that. So that one, and that one are all the same. So this is an equilateral triangle. What a mess. So this is my proof, equal. Okay, so I'm just going to highlight these for you. We've got sum of angles in a triangle. We have isos, which means it's the isosceles triangle that I'm dealing with. And then we have equal. Okay, so we'll start trying to do some solving. I'm going to speed up a little bit because I don't want to take too long with this. So when I look at this first diagram, I know that this is the first angle is 53, the second angle is 56. This is the problem that we're going to find with some markings. Based on what I just said, you're probably looking at these little angle measures and going, but Miss Greenhill, you just said that if they're all marked off, it means that they're all the same. Some of these diagrams we're going to come across and find that they're not the same. So I'm just going to come in and make that a double. Okay, so this X is a single angle marking, and the 53 has 2. 56 is going to have 3, if I can do this. Blah. It looks like a mess, but you get my drift. So that basically tells you that all 3 of those are not equal, that they all have their individual markings. So if I know that I'm going to take, and again, try and solve this algebraically, X plus 53 plus 56 is equal to 180. And remember, so far, we only know that SAT and supplementary are my only things that have to do with 180. So this, I don't know why I just highlighted in gray, but hey, it looks pretty cool. That is whenever you have equal something, this something on this side of your equation is the thing that's going to match your proof at the end. So as I just said, supplementary and SAT are the only 2 proofs that I know that deal with 180. So I'm going to keep that in the back of my mind. You don't have to write all that up top, but that's the stuff that I'm kind of thinking of. So 53 plus 56. I know 50 and 50 is 100. 3 plus 6 is 9, so I know it's 109 equals 180. That's an 8. Oh my gosh, what a mess. So X is going to equal, and again, if you're a balancing person, your next step is going to be to get rid of that 109 on that side, which means you have to get rid of it on that side. So let me erase this guy. I did that by accident. Doesn't seem to want to erase. Okay, doesn't matter. I'll do what I typically do on the whiteboard with you guys, which is just sort of cover it all over. Oh, I made a mistake. Let's just scratch it out. Okay. So X is going to equal, if you're an inverse operation person, 180 minus 109. Okay, and then we just solve that guy. Whoops. So 180 minus 109, 180 minus 110 is 70, so 180 minus 109 is going to be 71. And then I have to put my unit of measure, so degrees. And then this one, I'm going to go back up to here and go, okay, so far I know SAT and supplementary are equal to 180. And in this case, I'm dealing with a triangle, so I know that this is SAT, sum of angles in a triangle. So that's my proof, okay? We'll do one more. So again, same deal. So, oh, now it's G, of course it is. Okay, G plus 87 plus 19 is equal to 180 degrees. So G plus 106 equals 180. Okay, if you're a balancer, You know that you're going to have to take 106 away from that side, which means you have to balance it on this side. If you're an inverse, if you're an inverse operations person, you're going to, I did it again, G equals 180 minus 106. So G is going to equal 74 degrees. And I know this because of sum of angles in a triangle. Okay? Hopefully, so far so good. Now we're going to get to a couple other things. All right. With this one, I couldn't take off one of the 60s, right? But say, for instance, you get a problem like this and it says X, okay? Again, we know this is an equilateral triangle. We know that because it's equilateral, all sides are equal. And we also know that all angles are equal. And that's the important part for our proofs right now, is that all angles are equal. So I can just come in and do x equals 60 degrees, and my proof is equal. You don't have to do any calculation. If you're not 100% on these kinds of things, because maybe learning these hatch marks is new for you, so you might not readily recognize them, you're fine with doing, 60 plus 60 is 120 and subtracting it from 180. And then if you're doing all those calculations, you're just going to have to say SAT as your proof. But if you see those hatch marks and for whatever reason I give you this to solve for one side, or sorry, one angle, you don't have to do any work. You're just saying that x equals 60 degrees because it's equilateral. Okay? Now we're going to get to my favorite, your favorite in mind, isos. Okay? So for an isosceles triangle, you know that two side lengths are equal. And again, in these, we don't even have hatch marks. But the reason why I know that these ones, those angles and those side lengths are equal is because they've given you the same variable. So if you have the same variable in a problem, you know that those two values are going to be the same. Okay, so that tells me I've got two angles at the bottom that are the same, and the 116 is going to be that area where, remember I said those two congruent sides are going to meet at an angle. And then that means that the other two angles are equal, so those two sides are congruent. If we go down to, we'll just skip down to this other line and start marking it off. The bottom says that they're both 47, so we have two congruent angles, which means that the side lengths that come off of those angles, like their arms of those angles that are sort of sharing that same base, those are congruent. Okay, so, and then again, if you need it, right, those two congruent sides meet up at that third angle. So that third angle always has its own value. It doesn't share the same, it's not congruent with anything else. Okay, so let's get back to doing some solving here. In the case of what we have in front of us with this 116, I know that I've got b's, two b's that are the same. So I'm going to say 2b, or not to be, sorry, couldn't let that one go. 2b plus 116 equals 180 degrees. Okay, and I know that I just said with 180 degrees, you're dealing with either SAT or you're dealing with, that's a mess, or you're dealing with supplementary. But in the case of this, now the really paramount thing that we're dealing with is the two b's. So because we know we have two congruent angles, the SAT sort of gets canceled out, and we know that we're now dealing with our isos proof. So we're going to say, if you're a balancer, you know you've got to get rid of this 116. So we're going to subtract 116 from both sides. If you're an inverse operations person, you're going to say 2b equals 180 minus 116, and we have to kind of simplify that first before we start attacking this 2b. So 2b is going to be equal to 64. Okay, and then what we can do is we're going to divide both by 2, because this tells me that I'm doing 2 groups of b, which means I'm multiplying. The opposite of multiply is divide, so I've got to divide both by 2. This divided by that gives me 1, so I've got b left over, and then half of 64 is 32 degrees. So I know that b is equal to 32 degrees because of isos. Okay, mainly because I use this 2b thing. If you put SAT here, I'm still okay with that. But the isos theorem, the fact that we've got those 2 congruent angles, sort of cancels out the SAT. But use SAT if you're stuck. So now we've got this next one. We've got to solve for v. So I'm going to say that v plus 2 groups of 47, okay, or you can do 47 plus 47, it's fine, equals 180 degrees. Okay, and then we've got to simplify that, so that's going to be 94, I think. 47, yeah, 94 is 180. Okay, and then balancers, your next line is going to take those 94 away from both sides, right? It's a bit of a mess, but you get my drift. So if you're an inverse operation person, you're going to say 180 minus 94 on your next line, and then v is going to equal 86 degrees. And again, we solve this because of isos. Again, whoops, I forgot to put it into highlight mode. So we've got that 2 groups of 47. So those are your proofs basically. So now we're going to start mixing stuff up. So I hope you're ready for this. So we know that we have isos here. We've done equilateral, which in my opinion is the easiest one because you already know 60 degrees. 60, 60, 60. That's your equilateral proof. And then sum of angles in a triangle. Those are for your scalene. So you just learned 3 more proofs. Yay you. Now we're going to go to synthesizing some of this crazy. All right, so when we're dealing with this first diagram, we're looking at solving for S and for T. And you'll notice that this is a scalene triangle. So with a scalene triangle, I need 2 angles in order to get the third, and I don't have 2 angles inside of my triangle in order to get the third. But what I do have is this little guy, except he's outside. So now what we have to do is we have to kind of look at how to deal with these things. So I'm about to draw a big giant mark, and I'm going to erase it, but I just want to show you, unfortunately we're stuck with tech right now. On paper you can kind of turn your images around, and this one's now locked so I can't turn it. But you can turn your images around. The other thing you can do is cover parts of your images, your diagrams, with your hand or your fingers to help you kind of isolate things. So I'm going to solve this by coming in and just blacking all of that out. So now instead of looking at a triangle and seeing all that additional information, I now know that I basically have, well, it's not basically, I have a straight line here, and on that straight line there are 2 angles. So I know that a straight line tells me that if I add those 2 angles, they're supplementary, so they're going to equal 180. So unfortunately guys, I have to erase this or we're going to lose our whole diagram. but I just wanted to kind of show you the whole thing here. So I'm just going to get my pen size back to normal. So the first thing I'm going to do is solve for S. And I'm going to solve for S with a black pen. Okay. S plus 106 equals 180 degrees, because I know I'm dealing with a supplementary relationship right now. So if you want to isolate it this way, I can say right now all I'm looking at is the S and the 106. Okay, and I know that a straight line is 180, so I've got to figure out what this guy is. So those of you that are balancing, you know that your next line is going to show that you're taking away 106 from both sides. And then if you're doing inverse operations, we would have S equals 180 minus 106. So I know that S equals 74 degrees, and I know it because of that relationship over there, which is supplementary. Okay, then what I typically do, because you're going to find, I'm going to see how far I can push you guys. Being online, it's sort of tricky getting you to do all this at home. In class, you'd be showing up for class with diagrams all over the board, and we would be trying to solve them. So this guy's 74. What I do is I write the things that I've solved at the time. So again, what I'm going to do is I'm going to come in and I'm going to black out what I no longer need. So I don't need that anymore, because now I have, now I know that this is 64, and I know that that's 74, so I now don't just have to find that other angle. So again, we got to undo all this blacking out stuff, because I want you to kind of look at it as it is. But that's something that you could do. Like, that's my example of you sort of blanking things out as you go, or covering things over as you go. So now I know that if I take the angle T, whoa, I forgot to make my little point smaller. If I take the angle T and I add it to the other two angles, 74 and 64, I'm going to get 180 degrees, because this is a scaling triangle. Okay, so I'm going to simplify that. So 74 plus 64 is 138, and it's still going to equal 180 degrees. And then balancers, you're going to come in. I'm trying to save some space. I don't know if you noticed, because we're running out of space on the bottom here. We're going to minus 138 from both sides. So T is going to equal, if you're an inverse operator, T is going to equal 180 minus 134. And then we're going to simplify. T equals 42 degrees. And I was working within a scaling triangle, so I know it's SAT, sum of angles in a triangle. This next diagram I put there because I knew I was going to run out of room down here. Okay, so this next triangle, you should see, you got to read your triangles and your diagrams for information. The first hunk of information I have here is this. So I know that I am dealing with an isosceles triangle, and if I listened to Miss Greenhill before, those two congruent sides that were just highlighted means that they both meet at a shared angle, and that shared angle has nothing to do with congruency. That's the third angle out. So once I know that information, I'm going to have an aha moment and say, oh, wait a minute, X just is the same as that other angle that's there, because the markings even show you, that's so silly, the markings even show you the congruency, but again, don't always trust them, because you saw the last triangles that we had on the in the other examples, they were all marked and it was scalene. So you have to know this based on some of the other markings as well. Excuse me, as well. So I can just get away with saying x equals 45 degrees because of isos, and I'm done. So if you don't have to do any other work, but just state that. If I did ask you to solve for this shared angle, then you would go in and start doing calculations, but we're not here to do that. It just asked you for x. Okay, so complex, complex, complex. So I look at this and I say, holy cow, I need to have this, and I don't have either of those angle measures. But what I do have is exterior angle measures with my triangle, like outside of my triangle. So again, I'm just blacking this out. So if you see that, you know that you've just got a straight line with two angles on it. So let's just start there, right? So what you can do is you can start assigning, I did it again, you can start assigning variables, because you know that you're going to need to label something. I call them X, and that's a Z, believe it or not. So Y and Z, X, Y, and Z. You could have just done A and B. It doesn't matter. It doesn't have to stay in alphabetical order. So we're going to start with Y. So I know that if I take Y and I add it to 122, I get 180, okay? Because that's a straight line relationship. If I'm a balancer, I'm going to take 122 away from both sides. If I'm an inverse operator, I'm going to say is 180 minus 122. And then I'm going to say that 180 minus 122 is 58 degrees. And I know that because I'm dealing with a supplementary relationship. Okay, so I can't come in and say that it's SAT just because it's 180. Then I'm going to go, again, we're going to make the pen fat, and we're going to cover stuff over. If I want to find Z, I know that Z and 122 have a supplementary relationship as well. Now, I want you to kind of look at this, though, because if both of my exterior angles are 122, then that means that when I do a supplementary relationship, Z and Y are actually the same. They have the same value. They're congruent. So we could say that Z equals Y, and it equals 58 degrees. Whoa. And you can get away with saying isos here. Okay, so we just discovered that that angle and that angle are the same because their exterior angles are congruent. So now I know that Y equals 58 and Z also equals 58, so I put that on my thing. So now I know that this and this is happening, right? So I know that this isos relationship is in there. So I know that X plus two values of 58 is equaling 180. So I'm going to simplify the 58 times 2, plus 116 equals 180. If you're an inverse person, you're going to subtract from both sides. Or no, sorry, if you're a balancer. If you're an inverse person, you're going to bring that over. And then we're going to subtract, right? So X equals 180 minus 116, which is 64 degrees. You know this because you started with this 2 times 58, so that tells you that you're dealing with an isosceles relationship. So this is still isos, okay? I don't know if we're going to have enough room for this other diagram. It's insane on that side. Okay. Let's see what we can do here, guys. So I know that this equals 90, okay, because it's a right triangle. I know that these, I'm going to highlight them, these two side lengths are the same, which means that this is its own individual angle, but it's also going to mean that that angle and that angle are the same. So we're dealing with some seriously crazy stuff. So remember that when you are dealing with, because we can isolate this and say, okay, I know this is a straight line, so I know I've got supplementary, but the x has two other angles that it's sharing with. I have no information down here for this supplementary relationship, so I can't do anything with it. I also know that I've got these congruent side lengths, which tells me that I've got angles that are congruent. So I know that if one side's 63, then I know the other side's 63, so I can get in that way. So I can figure that out, right? So that's, I think, where we're going to start. So this angle we don't know, sorry, the little red angle we don't know, but because of these hatch marks, I know that this guy's going to equal 63, so I just have to write my proof. I'm going to call this y, okay? So I'm going to say y equals 63 degrees, and I know this because of isos, okay? So we're just going to assign variables, and we're going to start solving things as we go, because it's madness, I tell you. The next thing, now I've got two angles in my triangle, so I'm going to call the third one z. So I'm going to say z equals, sorry, I'm not going to say z equals, z plus two values of 63 gives me 180 degrees. So I'm going to say z plus 126 is going to give me 180 degrees. If I'm a balancer, I'm going to subtract from both sides. Subtract from both sides. Okay, so z's going to equal something. 180 minus 126. You guys know I'm using my calculator. I'm not going to hide it. And that equals 54 degrees. And remember, I know this because of this 2 times thing, so that tells me that I'm dealing with an isos relationship. We can have enough room, maybe. So this is 54. Because remember I told you I tend to do these as I go along, like I fill them in. So now on my second triangle, so the triangle to the right, I already know that this is 37. We've already established that that's 90 because of this little box. So I just need to find this third guy. So I've run out of letters in my alphabet, so I'm just going to start from the beginning. I'm going to call this one A. So I'm going to say A plus 90 plus 37 equals the total angle in a triangle, total angle measures in a triangle, so that's 180. I'm going to simplify first. So 90 plus 37, and 127, oh, I should have been able to do that in my head, is 180. If you're a balancer, I'm going to have to use another line here. If you're a balancer, you're going to subtract 127 from both sides. Okay, if you're an inverse, you're going to say A equals 180 minus, I'm running out of room, 127. So A equals 53 degrees, and I know this because of the sum of angles in a triangle. Okay. and we haven't even solved y yet. So, or sorry, x. So I'm going to come over right to the left, to the very, very left side. And I'm going to say, now I know that this is 53. Okay. I'm going to say that x plus 54 plus 53, all of those together on that straight line give me 180 degrees. So I know to simplify, x plus 107 equals 180. If I balance, I'm going to subtract 107. Oh my gosh, this is a mess. And subtract 107. So now I know that x, if I'm an inverse person, is 180 minus 107. Why won't my pen work? there it is, 7. So x is going to equal 73 degrees. That was my straight line relationship, nothing to do with triangles. So now we go back to sup. Okay, we're almost there, guys. Okay, so to summarize, if I have an angle and another angle and a third angle and none of them are congruent, I'm dealing with SAT, sum of angles in a triangle. If I have this and I know underneath those two, or I know that they're the congruent congruent angles, I'm dealing with isos, okay? And if I have those three, which means these three, then this is equal. Whoops. So that is in addition to my kissing fish, which is opposite. This is in addition to this, which is complementary. And it's in addition to this, which is supplementary. Okay? So if you're done, you can be done. Practice those, work on those. If you want to do a little bit with some algebra, then follow along. If not, go do your homework. Okay, so if we're dealing with algebra, the first thing I know with this diagram, I'm going to speed up because those of you that are doing algebra, you could probably handle the speed. I know that because of this and because of this, that this angle and this angle are congruent. So I'm dealing with algebra. Congruency means equal, so I'm going to balance those. So 6x minus 1 is equal to 77 because the diagram tells me they're congruent. So we're just going to go through and we're solving for x, right? So 6x equals 77 plus 1. 6x is 78. Divide both sides by 6. So x, whoa. You guys notice that I can work my way up. I just can't work my way backwards. I'm not good at subtracting mentally, and I'm not good at dividing mentally. I don't know what the block is. So x equals 13 degrees. Well, it doesn't equal 13 degrees. Sorry. X equals 13, right? So if I substitute x back in, this should equal 77. So that one's a little bit more straightforward than the second one. The second one, we're solving for x and y. So what we need to know out of this diagram is that these two angles are congruent based on the markings on the diagram. So I'm going to start with those two. I'm not going to start with 9x. So 8, there we go, pen, there we go. So 8y minus 16 is equal to 72. Um, 8y is 72 plus 16. 8y is 88. Divide by 8, right? 7, 8, yeah. So y is going to equal 11. So we've solved for y. If I know, I can solve this a few different ways, so I'm just going to solve it this way. I know that this equals 72, which means therefore that equals 72. So I'm going to say 9x plus 2 groups of 72 is 180. Okay, so we're using those properties, but we're doing this in a different way because we're actually solving for the variable. 9, so that's 144. So that equals 144 equals 180. 9x equals 180 minus 144. 9x equals, what is that, 146? I just want to double check because, again, I don't trust myself. 36. Wow. 36. Divide both sides by 9. 9. So x is going to equal 4. Okay? So notice the difference between these is, and the other ones. The other questions, you're using geometric proofs. These, you're using your understanding of the proofs in order to solve for variables. So we're not actually solving for angle measures. Okay, so those are a few challenge questions. Go back to the slides, check out your homework, and yeah, talk to you guys later. Enjoy.